Solve the following Bernoulli's equation. So Bernoulli, because this is in the following form. We know that when we have a function dependent variable y and some function of independent variable, let's say px something, plus a derivative of y with respect to that independent variable dx. If there is something, we can always divide through by that. Okay, if we have dy over dx plus pxy equals some function in terms of x, where x is the independent variable. Okay, the coefficient is in terms of x, y dy over dx, and the coefficients are only x. Then this is linear in y with respect to x. This is linear. Okay, this y dependent variable, we can have anything. We can have v is still linear in terms of v, linear in v with respect to x. This is dy over dx. So we almost have this, but there is y square. Here is a y square, that's the dependent variable. If we did not have this, then we would be exactly in this case, linear. So this is non-linear because of that. So our goal here is to make this linear with a correct substitution. So what we do is, okay, just to make linear, y square is causing the problem. Let's move y square to the left, means divide both sides by y square. So divide through by y square. So here is 1 over y square, and I got y prime, which is dy over dx. Divide by y square. So 4 over x, y over y square means 1 over y equals x cubed. Okay, I mean this is not linear, but at least the right hand side is now good, function of x. But then we have to have just the y or some dependent variable and dy over dx. But here is a fraction. Okay, x is still independent variable. So if we let 1 over y, if we assume that to be v, and somehow we can able to convert this into derivative of v with respect to x, okay, then this becomes like, this is v and here is dv over dx. So linear in v with respect to x. Once we have a linear differential equation, we can find the integrating factor and solve. So that's what we do. So we let v be 1 over y, and this will be automatically converted into some constant times dv over dx. Okay, that's the goal. This is how we solve these Bernoulli's problems. Okay, so 1 over y, let me keep this is our v. So let v be 1 over y. So we are trying to convert this differential equation in terms of v, and x is there as well. Okay, 1 over y. So we want to convert this in terms of dv over dx. So let's find the derivative of this v with respect to x. So v is a function of y and y is a function of x. That means v is also a function of x. So we can find the derivative. Then derivative of v with respect to x. Okay, find the derivative is using general or implicit differentiation. Okay, 1 over y, we know 1 over x. Derivative of 1 over x is negative 1 over x squared. So this will be negative 1 over y squared, but we are doing with respect to x, so times dy over dx from the chain rule. Okay, and here we are supposed to get dy over dx replaced. So dy over dx will be is a times, so multiply both sides by negative y squared. So this is same as negative y squared dv over dx equals dy over dx. So I am isolating dy over dx so that I can replace dy over dx here and get in terms of v. Okay, then with this, let's say this one is a star, then with these substitutions the equation star becomes 1 over y squared, we don't have anything yet, dy over dx we found here, that's negative y squared dv over dx, plus 4 over x 1 over y, okay, we made that linear, v equals x cubed, and they cancel. I mean, this will be always, there should not be any y's left. I mean, that will be the case as long as we have a Bernoulli. So we got negative dv over dx plus 4 over x v equals x cubed. So this is pretty much in this form now. If I replace y by v, still linear. So this is linear in v with respect to x. Okay, the coefficient is 4 over x, the coefficient is negative 1. But we need to get rid of this negative so that we can find the integrating factor for multiply through by negative 1. So dv over dx minus 4 over x v equals minus x cubed. So this is linear in v with respect to independent variable x. Okay, to solve, we're going to find integrating factor. So integrating factor is e raised to integral whatever we have in front of v. So in this case we got negative 4 over x. So negative 4 over x dx, that is e raised to, oh, there is a negative sign, so negative 4 can be pulled to the front, 1 over x dx, e raised to negative 4, antiderivative of 1 over x dx is natural log of x. In fact, this question is kind of incomplete. It's always given that x is positive. Okay, that means the absolute value is not needed. And then now we just find this one. So here, to get rid of e and natural log, they have to be adjacent, but this 4 goes here, then e and natural log cancel, x raised to negative 4. Now then this linear, let's say star, double star, after we find the integrating factor, we multiply both sides by the integrating factor, and when we multiply both sides, then automatically we've done before, then equation double star becomes, in the left side, derivative of dependent variable times the integrating factor. That will be always the case. Okay, when we have a linear ODE and we find an integrating factor, then we multiply through by the integrating factor. The left hand side automatically becomes derivative of a product, which is dependent variable, in this case v, times integrating factor, is equal to, let's multiply right hand side. We got, let me multiply over here, I got negative x cubed in the right, and we are multiplying by x to the negative 4. X to the negative 4 is in fact 1 over x4. Okay, x, three copies from top and bottom cancel, negative 1 over x. Now we integrate both sides with respect to x, then integrate, we get v times, this is 1 over x4, integrate minus integrate 1 over x, that's the natural log of x, and x is positive, so we don't need absolute value, plus c. So let me put here though, plus c is separate. Okay, now we can isolate v, and v is 1 over y, and eventually we can isolate y. So multiply both sides by x4, so v equals, when we multiply through by x to the 4th, so negative x to the 4th ln x plus c x to the 4th. Okay, I multiplied through by x to the 4th. but v is 1 over y, so this is 1 over y. Okay, just to save room, so I'm going to write extra one step here. This is 1 over y, so 1 over y equals this junk. Then what is y? So 1 over y means we need to take the reciprocal, so 1 over y equals this. Okay, that's the extra step I just squeezed here. So y equals 1 over everything. Okay, do not try to separate. Everything means negative x4 natural log of x plus cx4. Okay, that's the final answer. So y in terms of x.